Okay. Good morning, everyone. Today we will discuss about perpendicular axis theorem. Okay. So let's discuss what we mean by perpendicular axis theorem. Okay. We should know. Okay. Perpendicular axis theorem. Okay. For applying the perpendicular axis theorem, we should know we can apply this perpendicular axis theorem only 2D objects. Okay. So firstly, we can apply uh, for this perpendicular axis theorem for 2D objects. Second thing, like uh, like laminar, like lamina we know as 2D lamina, 3D, 2D lamina like rectangles, a square, etc. And let's write down here apply. We can apply only for the 2D object this perpendicular axis theorem, and the statement for this IZ, that means what, the moment of inertia with respect Z axis, this will be sum of moment of inertia at axis x plus moment of inertia of y-axis. Okay. So this is a statement for perpendicular axis theorem. Okay. So one thing, if you really want to apply this perpendicular axis theorem, we have some kind of conditions. And what is this condition? First is x, y and z should be mutually perpendicular. Okay. Like okay, let's make a diagram for this. We have this plane. Okay. And here's some kind of body we have, like this. Okay. And where's the plane? Why not? Okay, yes, this is the axis. This is actually z axis which we have, and this will be our x axis, and this will be y axis. So one thing you can see here, all the axes x, y, z all are perpendicular to each other, mutually perpendicular, we can say this. Okay. Next, second point is this, which is very important, you should remember this. X and y axis should be in the plane of body. Okay. And third thing is what, z should be perpendicular to plane of the body. Okay. So these three things are very important to understand the perpendicular axis theorem. If you really see this kind of things like x, y, z should be mutually perpendicular, x and y axis should be in the plane of body, z should be perpendicular to the plane of the body, then we can say, that means in this condition, if these conditions are valid, then we can apply this perpendicular axis theorem, which is very important to the exam purpose and JE and JE and NEET purpose. Okay. So so this is the statement. Okay. let me erase. Not okay, let's see the proof of this uh, perpendicular axis theorem, which is very easy. Actually, for this, for the moment of inertia, in moment of inertia, we have done a lot of things like uh, moment of inertia for the rod, moment of inertia for hollow cylinder, solid cylinder, cone, and hollow cone. So you should know about the previous things, which is very important to understand this perpendicular axis theorem. Okay, so let's move on a pen and let's change the color to understand better way. Okay. So let's assume firstly, as we know, the formula for moment of inertia of any body, moment of inertia. Okay, let's assume there is some kind of mass in xy plane. Okay, there's a mass in xy plane. This is actually 2D surface, so we can't imagine proper way. But if you draw this distance from y-axis and x-axis, let's draw this distance from here. Okay, this distance. Okay, this distance we call x, and from this distance, okay, this distance we can say y, and some distance from the center, this we can say this is r. This is the resultant actually, and this is the mass here as we assumed at xy plane, dm at xy plane we can say. So as we know, at the actually x-axis, the moment of inertia for this body dm at x-axis, that means for dix, is equals to dmy square, as we know. Similarly, the moment of inertia of at y-axis, it will dm x square. Similarly, moment of inertia of z-axis with respect of z-axis, dm r square. So we know that r is nothing but r square equals to x square plus y square. So we can write down diz is nothing but dm, and the resultant r square is nothing but x square plus y square. If you open the bracket, dmx square plus dmy square. Okay, and here you can see this diz, okay, and diz is equals to here you can say dmx square is nothing but from here diy, d, that means moment of inertia with respect of y plus moment of inertia with respect of x. Okay, as we know the simple things, you should know about that. Okay, now if you want to find out the moment of inertia of whole the body, this is actually this moment of inertia for this small body dm. If you really want out the actually find out the value of whole the body, moment of inertia of whole the body, take an integration. Okay, after integrating this, you can see here diz is equals to integration of diy plus integration of dix. Then finally we can write down iz is equals to iy plus ix, and this is the perpendicular axis theorem. Okay, you can see we have proved it. So this is a very important question to the purpose of JEE Main and Advanced also. So you should know about this perpendicular axis theorem. Okay, so this was a very easy question. Let's actually derivation. Let's move on the another question. Okay, one thing, let me take a eraser and erase it. Okay, write down. Let's erase it. So we will discuss one question from here. One thing, let me write the question. Question is, this is the disk which we have. Question number one actually. One not. Let me take a pen here. Okay. So let this is the a circular disk. This x-axis passing through this disk from the center, and this is also not. This is also a z-axis, and this y-axis passing through this center is actually disk having mass m and radius r. Okay. This is the y-axis, this is z, and this is x. Find ix, moment of inertia with the respect of x-axis. So in solution we can see, let me change a pen, one minute. Okay. In solution you can see here, we have this the disk. It's a very easy question, don't worry about that. Okay, so this is the z-axis, this is x, and this is going from here, this is y, this is y, this is z, and this is x, and this is the disk which we have having mass m and radius r. One minute. Okay, so we know the moment of inertia. Actually, firstly, this z-axis passing through this disk, so we have the moment of inertia for this z-axis mr square divided by 2. Okay, we know about that, we know. Okay, we know this moment of inertia. Now we know the perpendicular axis theorem. Perpendicular axis theorem, you can write down iz is equals to ix plus iy. So you know the value of iz, mr square upon 2, and here you can see from the symmetry, from symmetry you can write down ix plus iy should be equal to ix, then this is the 2ix, and here mr square upon 2. Okay, if we will solve this, we will get ix equals to mr square upon 4, and this is the moment of inertia of given disk. Okay, very easy question, so you have to solve this question properly. Okay, again the same question for the ring. Actually this is the question was for the disk, we will solve same question for disk. So let me erase it. One minute. Let me erase it. Okay. Find here also we have to find out the moment of inertia. Okay. So condensed. Okay, one minute. Where's the pen? Actually question was very easy. Last question was very easy. Now we will discuss about another question. This is also very easy. Okay. So this is the y-axis and this is the ring which we have, and this is x-axis having mass m and r. This is actually ring. We discussed the question about the actually ring. Now we will discuss about ring. Okay, so again in solution, let me use another pen. Okay, so here we have a ring having mass m and radius r. We know if we have this is disk, so this ring, and this is z axis, this is x axis, and this is y axis passing through this coordinate system. Now this is y axis and this is x axis, and okay, and having mass in r. We know for the moment of inertia for this z axis, Iz is equals to mr square, moment of inertia for this ring. Okay, we know mr square. Then from perpendicular axis theorem, we know Iz equals to Ix plus Iy. So here you can see the from symmetry we can write down 2Ix, and Iz is nothing but mr square. So 2Ix, we can find out Ix from here. Ix equals to mr square upon 2, and this is the moment of inertia for this ring. These are the question which is very easy. You don't have to need like panic. This question was very easy. So we should know about this perpendicular axis theorem. Okay, for some examination there are people asking about the statement of this theorem. So let's write this statement for you. Okay, let me erase it firstly. Let me erase it firstly. Okay, let's move on another statement of this perpendicular axis theorem. Statement for examination, this statement you can write down. The proper statement is the theorem states that it states that the moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to the sum of its moment of inertia about two mutually perpendicular axes concurrent with perpendicular axis and lying in the plane of the laminar body. This is a statement, and as we know, the mathematical statement Iz equals to Ix plus Iy. So this was the perpendicular axis theorem, which is very important to the exam purpose. So stay tuned. We will meet after the next session. Okay, thank you very much.